Okay, so continuing our lecture, what we want to go ahead and do is look at the public class post. What have we done? We've made some changes. We now have public class. We've got these variables. Public class is a constructor. We're creating a generic array list now, and then we're not including the methods on this slide at this time. But notice that the constructor is already different, where before we had two, now we only have one, and we make it a generic one. Message post extends post. Notice this code is much more simplified, more significantly simplified. It's only doing a couple minor things, but this is the key change that you would see. Superclass constructor call. So one of the things that's very interesting is when you call the superclass for a constructor, if you don't do this, the compiler inserts one without parameters automatically. If you do this, then you call it however you want. It must be the first statement in the subclass constructor. Alright, so we'll see an example of that in a little bit as we go through our code. There are some examples put in there. So in this case, if we wanted a new one, we already had message and photo, now we're going to add event. So this is the only difference, is event type, and likewise it would inherit as well. Just giving you examples of more. Then what you could do is further inherit even another level down. So you could have a commented post with common things between these two put up here and have message post and photo post. So you can continue to do this if you wanted. There's a lot of ways you can do it, but the nice thing is if you did insert a level of inheritance, you simply change the extends here, add this new class in, and you're off to the races. Review so far. Inheritance helps with avoiding code duplication, helps with code reuse, kind of the same thing, just reverse in the way they say it. Easier maintainability and better extendability. You can implement methods of your own. If you're developing your own framework, I suggest that you create a generic object and everything in your framework is inherited from that. This way you can go ahead and change things at the root level if you need to, such as languages, security, stuff like that. Subclasses and subtyping. Classes define types, subclasses define subtypes. So in other words, if this is a child of this, it's a subtype of this. Objects of subclasses can be used where objects of supertypes are required. This is called substitution. Important concept. So in this case, the way we're doing this is vehicle is a new vehicle, vehicle is a new car, and is a new bicycle. So in other words, vehicle is capable of handling itself and all of its child classes as well, or subclasses. This is a very different concept, but is very, very powerful and will be used in the network example that we're doing. So in this case, public class newsfeed, we're creating an array list of post, which is going to hold a bunch of different types of posts. Remember, this could also be empty if you wanted. Public newsfeed, array list, open close, public void add post, etc. Okay, so this is pretty straightforward. There's nothing really exciting or different here, more of the same. They're just showing you examples of how to do this stuff. You have your news feed, etc. And it's fairly straightforward. Okay, post, this is where it creates a new one of these. Just looking through this for anything different. Newsfeed source code. The show method now, remember before we had two different for each loops, now I have a single for each loop. And as long as I have display defined correctly, I'm able to just run with this and be done pretty easily. This is a very nice addition because now my post will actually come in chronological order versus all of one type, then all of another type. So first we had add message post and add photo post. Now we just simply have add post. Why? Because post is the parent, so everything can go through this one style or one piece of code. We call this method myPhoto equals new photo post, feed.addPost myPhoto. Add post is singular, which is very nice, and you can pass in any of the different types of child subclasses. Public class newsfeed, void add post. Down here you have a photo post, photo equal new photo post, message equal new post, and again it's just showing you how I create a new photo post, I create a new message post, and I simply call the same post method in both cases. This may be confusing to you, but just think of it as, because these have the same parent, I now can send them through the same type of processor where before they had to be completely separate. So what does this look like in terms of an object diagram? Newsfeed now just has a collection of posts. I have an array list in here of posts, and here you go. Here's a collection. Whatever order they show up in, doesn't matter to me. They're all able to be stored in here because of that unique feature that Java has. What does a class diagram look like? News item uses post, and then these two inherit from. Okay? Very straightforward, nothing overly imaginative. Polymorphic variables. Object variables in Java are polymorphic, meaning many forms. They can hold objects of more than one type. They can hold objects of the declared type or of the subtypes. In other words, they can hold of themselves and any of their children. That's all that's saying. It's confusing in the way they write it, but that's really all they're saying. Of itself and all of its children. Casting. This is one of the issues that you'll run into now, is you have to take into account this concept called casting. So we can assign subtype to supertype, but we cannot do it in the reverse. So in other words, a car can be assigned to vehicle, but a vehicle cannot be assigned to a car. Think about it. Car has additional methods, variables, and things like that. How would vehicle have that? Vehicle would not know what to do or how to get it in there. Okay? Now, it does trust you. If you know for sure that your vehicle has everything you need, you simply cast it as car, and then you can stick it in. So this is called explicit casting or casting. It helps you convert vehicle into a car. But notice this, but only okay if vehicle really is a car. So in other words, if I did this up above, and now I need to get it back out, and I'm going to go ahead and cast it. Why? Because if vehicle really is a vehicle, like I said up here, it's missing all the information you need, so it's not going to know what to do with that, and it's going to be missing the methods and the variables that it needs, and you'll have bad things happen later. An object type in parentheses is how you cast it. You simply give left, right parentheses around it, just like what you saw up above, right here. Used to overcome type loss. In other words, this is type loss. When I put a C into a V, okay, it no longer knows what this type is per se. You have to track it to get it back out. The object is not changed in any way. A runtime check is made to make sure, and it will throw this type of an exception. We'll get into an exception handling situation in a couple weeks to help you figure out how to do it. Use it sparingly. It's a really neat shortcut, but if you do it too much, you can actually cause yourself maintainability problems later. So let's look at an object diagram. Everything in Java is inherited from objects, so conceptually you could already do it. String, person, vehicle, all of these ultimately come from object. Car and bicycle are coming from vehicle. This is just showing you an example of an inheritance tree that you can already have based on how you do this. Polymorphic collections. All collections are polymorphic by definition. Objects could simply be of type object, or elements could simply be of type object. The definition of add right now looks like this, meaning that you can pass in anything. Java doesn't particularly care. Public object get int index is just an example. I would avoid this, but you conceptually could do it. I would prefer that this was integer, but that's just my opinion. I'm sorry, I misspoke. This is a way of getting it, so it returns an object type of an integer with the index. So index is a number between 0 and n, where n is less than the total number of objects in that array list, and it always returns of type object. You actually take care of putting it into the correct place. Usually avoided by using a type parameter with the collection. In other words, usually you don't pass in type object, you pass in explicitly what you want. Polymorphic collections. A type parameter limits the degree of polymorphism. So in other words, once you've done this, you hold on to just objects of post and any of its children. Otherwise, it looks like this, which could be anything under the sun, which could actually cause confusions for the network feed that we're doing. Likely get unchecked or unsafe operations warnings when you do things like this. Try to avoid it. Just plain and simple. You want your compiles to be as clean as you can. More likely to have to use casts. If you do this route, you'll have to cast things more likely. be as restrictive as you reasonably can based on your design and future intentions. To review this lecture, inheritance allows definition of classes and extensions of other classes. In other words, I can extend parent classes into subclasses. Inheritance allows you to avoid code duplication, code reuse, simplifies the code, helps with maintenance and extending. It can make actually code harder, but that's usually a rare circumstance. It's not by design. If you're developing properly and you're having self-documenting code and a good design, you'll go ahead and do it. Variables can hold subtypes of objects. In other words, the parent can hold itself or any of its children objects. Subtypes can be used wherever supertype objects are expected via substitution. With that, that's the end of lecture 10. There will be an additional lecture on the network code. It's simply going to review the code a little more and go from there. Hopefully you got something out of this lecture. As always, send me an email with your questions and I'd be happy to help.